Welcome to today's Explainer. We are going to embark on an absolutely incredible cosmic journey today to explore the weird, mind-bending worlds existing far beyond our own solar system. If you've ever looked up at the night sky and wondered if there's anything else out there and just how bizarre those places might actually be, you are in exactly the right place. We're going hunting for some truly strange and fascinating exoplanets.
But first, I want you to picture something for a second. Imagine stepping outside, looking up at the daytime sky, and seeing not just one, but multiple suns blazing down at you, casting overlapping shadows all over the ground. It sounds exactly like a scene straight out of a big-budget sci-fi movie, right? Well, today, we're going to dive into how this sci-fi concept is actually a totally established astronomical reality.
To get how wild this is, we have to look at how much our perspective has changed. For literally thousands of years, humanity lived under the very firm illusion that our solar system was a one-off. We thought our setup was an incredibly rare phenomenon. But then the 1990s hit. Astronomers finally confirmed the very first exoplanets, planets orbiting distant stars. And bam, it instantly opened up a brand new era in astronomy. It completely rewrote our understanding of the cosmos. Fast forward to today, and our powerful telescopes haven't just found a handful of new planets, they have completely shattered that old worldview by confirming thousands of exoplanets. Literally thousands! This massive number proves without a shadow of a doubt that planetary systems aren't rare anomalies at all. They are incredibly common throughout the Milky Way. Honestly, we live in a pretty crowded neighborhood. That brings us right to Section 1, Strange New Worlds, and the bizarre zoo of exoplanets. What's truly astonishing here is the sheer diversity of what scientists are actually finding. We aren't just bumping into simple Earth clones out there. Far from it. We're finding strange and fascinating exoplanets that completely defy expectations. For instance, we're discovering these scorching hot gas giants orbiting dangerously close to their host stars. Imagine a massive planet like Jupiter, but locked in an orbit so incredibly tight that its atmosphere is literally boiling away into the vacuum of space. And moving from the fire to the water, we're also seeing evidence of strange, rocky worlds that are fundamentally different from Earth. We're talking about planets completely engulfed by deep, global oceans. No continents, no islands, no land masses at all. Just a relentless, endless expanse of water covering the entire globe. Then, swinging from boiling gas and endless oceans to the absolute other extreme, we find exoplanets completely trapped beneath entirely frozen, icy surfaces. Just desolate, silent worlds locked in a permanent, unimaginably deep freeze. To cap off this incredible variety, and to answer that question we asked at the very beginning, yes, we have actually found planets that have multiple suns shining in their skies. It's wild. The strange and fascinating exoplanets we're uncovering really prove that when it comes to making planets, the universe has a remarkably wild imagination. So let's get into Section 2, the detective work, and how scientists actually find these invisible planets. You might be wondering, how do we actually spot these distant, faint worlds when they are orbiting such blindingly bright stars? Well, let's break down the two primary, incredibly clever methods scientists use. First up is the transit method. This is essentially watching for a winking light. When a planet passes directly in front of its star from our point of view, it briefly dims the star's light, just a tiny bit. The second trick is the radial velocity method. Here, we aren't looking at the light dimming, we're looking for a wobbling star. A planet's gravity physically pulls on its host star as it orbits, causing a tiny, measurable wobble. It's just brilliant, brilliant detective work. Which leads us to our third section, searching for another Earth, which is often considered the absolute holy grail of modern astronomy. Now, while those strange gas giants and frozen worlds are endlessly fascinating, astronomers are laser-focused on finding Earth-sized planets. So the crucial starting point is knowing exactly where to look. We are looking for the habitable zone. That specific region around a star where conditions are just right, not too hot, not too cold. It's that perfect Goldilocks orbital distance where liquid water can actually pool on a planet's surface. Because where there's liquid water, there's the potential for life as we know it. And the tools we use to find these specific worlds have evolved so fast. Modern planet hunters are specifically targeting Earth-sized planets right now.
Thanks to specialized space telescope missions like Kepler, our capacity to search the cosmos has expanded dramatically over the last couple of decades, and that legacy is being carried forward right now by the TESS mission. It is constantly scanning the sky day and night, specifically hunting for these potentially habitable Earth-sized worlds.
Okay, but what happens if we actually find a planet sitting perfectly in that habitable zone? Well, then scientists start looking for what we call biosignatures. These are chemical clues hidden in a planet's atmosphere, gases like oxygen and methane. Finding the right combination of these gases could strongly indicate biological activity. Basically, we're looking to see if the planet is breathing and giving away the presence of extraterrestrial life.
However, I gotta be totally straight with you here. It is deeply important to state clearly that as of right now, no confirmed evidence of extraterrestrial life has actually been found. We've found the strange and fascinating exoplanets, we've found the habitable zones, but the definitive proof of life, that still eludes us. The search is very, very much ongoing.
And that brings us to our final section, the ultimate question regarding our place in the universe.
To wrap up this explainer, we really have to consider what this ongoing search means for us as a species. A quote from our source material captures it perfectly. It says, "Every new exoplanet discovered reminds us that our solar system is only one small part of a galaxy filled with possibilities." It just perfectly captures the essence of this whole endeavor. Finding another Earth, mapping out all these strange new worlds, it's fundamentally a search for our own place in the vastness of the universe. It gives us that vital cosmic perspective.
So, I want to leave you with the final, provocative thought to chew on today. If, or let's be real, maybe when, our telescopes finally spot clear signs of life, a planet with oceans, a rich atmosphere, unmistakable biosignatures, what should we do next? Should humanity attempt to send a message and contact that potential civilization? Or is it wiser to just observe them quietly from a distance, in the dark? It's a question that challenges our ethics, our curiosity, and our understanding of our role in the universe. Thank you so much for joining me for this explainer, and keep looking up.